Okay, guys, sorry this is going up late. It's 9:30 here. Hopefully you're in bed by now, but whatever. Here it goes. So we're going to do rate of work problems, and they're similar to motion in that uh, an amount per time. Just like in speed, we had kilometers per hour or something like that. So you're going to have something similar to distance equals rate times time. So let's have a look at this situation. Colette and Flynn work on a boat. You can read. Goes on day trips around Vancouver. At the end of each day, the boat needs to be cleaned. Colette will take 2 hours, and my man Flynn takes 3 hours because he's a bit of a slacker. So we have to say to ourselves, logically, because what you always want to do is you say, well, it'll take him 5 hours. But that makes no sense, right? Because you want to say, well, it's Colette plus Flynn. Colette is 2, Flynn is 3, so it will take 5 hours. But that makes no sense because Flynn by himself would take 3, Colette by herself would take 2. So it must be less than 2 because Flynn is helping. So even though Flynn's lazy, Colette is still going to get done faster than 2 hours because Flynn is doing some of it. So what we have to do is we have to find ourselves a unit rate. And a unit rate is something that is done in one period. So what is the period that we are measuring here? We're measuring hours. So we have to ask ourselves, what does each do in 1 hour? So Colette, if it takes her 2 hours to do the whole job, okay, so whole job, 2 hours. How much does she get done in 1 hour? Unit rate. Well, if it takes her 2 hours to do the whole job, in 1 hour, she's going to do half the job per hour. Now we look at Flynn. Flynn's going to take 3 hours. So how much does he get done in 1 hour? A third in 1 hour. So then we say to ourselves, what's our total? Well, total time. Well, Flynn is going to get 1/2 done in an hour. So the time that Colette is going to take if they're working together is X, because we don't know how long it's going to take her. And Flynn is X, because they're going to take the same amount of time. Same, because they're working together. So we have to ask ourselves, if Colette does half the job in 1 hour and Flynn does a third of the job in 1 hour, so a half of X plus a third of X equals how much of the job is getting done? And of course the answer is 1 complete job. Right? So this is what I need to solve. Now, can I add those? No. I need a common denominator of what? Now, right now, Sam and Amshuman are sitting in their house going, 6! It's 6! So I need this to be 6. So normally we would say, well, that's times 3 and that's times 2, correct? Except This is an equation, isn't it? So I also need this denominator to be 6. So I got to multiply this side. I got 1/2 x plus 1/3 x equals 1/1. But I need that to be 6, which means I need that times 6. Now, because it's an equation, if I multiply this side by 6, what do I have to do to this side? Same thing. Everything's got to multiply by 6. So I get 6 divided by 2, 3x, plus 6 divided by 3, 2x, equals 6 times 1 is 6. 5x equals 6, x equals 6/5, or 1.2 hours. And that makes sense because it had to be less than 2 hours. So there's our answer. Okay? So let's go on and try a couple more. Here's our next one. Tim takes 4 hours to paint a room. Bob takes 3 hours to paint a room because Bob isn't a slacker. How long will it take them to work together? So let's set up our table. Tim, to do the whole job, takes 4 hours. Bob takes 3 hours. What's our unit rate? 1/4 and 1/3 per hour. And the time it's going to take them to get the job done is we don't know. So, we're smart kids. 1/4 is the amount it gets done in 1 hour, but we're going to multiply it by X amount of hours plus 1/3 X equals how many complete jobs? 1 complete job. Now, what does that mean? I need a common denominator. Amshaman? 12! Of course it's 12. So everything's got to be 12, which means this side's got to multiply by 12. This guy's got to multiply by 12. And this guy's got to multiply by 12. To get 3x plus 4x equals 12. 7x equals 12. X equals 12/7. Or, go to your calculator, 12 divided by 7, 1.7 hours. 1.7 hours. Or, if you want to get really technical, 1 hour, 1/10 of an hour is 6 minutes, 7/10 of an hour is 42 minutes. I don't care what you give me, that or that. They're both okay. Now, sorry guys, I skipped away from that pretty quick. I'll let you have a look at all the work for a couple of seconds. You can pause it there if you need to. All right, next. James, I got my man James, 40 minutes. I got my man Jeff, 50 minutes. So what do I got to do when they work together? I think to myself, self, it has to take less than 40 minutes. Answer is less than 40 because James could do it by himself in 40. So I've got James and I've got Jeff. James takes 40 minutes. Jeff takes 50 minutes. How much can James do? Now, here's where it gets different. What's my rate here? Is it hours? No, it's minutes. So I have to do my unit rate is per minute. So this becomes 1/40th of my roots per minute and 1/50th of my root per minute. How many minutes is it going to take? We don't know. That's the question. X, X. Then we work it out. 1/40th X plus 1/50th X equals 1 whole job. What's my common denominator? Waiting. Sam! Oh, wait, maybe Leighton got this one. It's 200, isn't it? So I got to multiply everything by 200 to get 5x plus 4x equals 200. 9x equals 200. X equals 200 over 9. And you go to your calculator, 200 divided by 9. You get 22.2 minutes. 22.2 minutes. If you want to get really technical, 22 minutes and 0.2 of a minute is 2/10 of a minute, which is 12 seconds. Again, I don't care. I'm more than happy with that. And finally, what happens if we know the time? Kyra mows the lawn in 40 minutes. When she asks, which of course, as you all know, that's when she forces her boyfriend to help, they finish the job in 24 minutes. How long would it take the boyfriend to do it himself, since she's probably only going to sunbathe the next time anyway? So we've got Kyra, and we've got the boy. Kyra takes 40 minutes. What do we know about the boy? How long would it take the boyfriend? We don't know. So that gets our letter. What's our unit rate? Well, Kyra is 1/40th, right? And the boy is what? Oh, I don't know there. But we do know our time, don't we? 24 and 24. So now we got to look at that and really think about it, because things are different this time, aren't they? Sorry about that, guys. I had to take care of something with the kids. So sorry. The unit rate here is B over, sorry, 1 over B, because we don't know how long the boy takes, right? So now we do know, however, the time they both take. So 1 over 40 times 24 plus 1 over B times 24 equals 1 whole job. Yeah? So now all I got to do is figure this out. 24 over 40 plus 24 over B equals 1. Now, what's my common denominator? What? We got a letter in the denominator. So the common denominator, as always, is 40 times B, right? So I got to multiply everything by 40B. 40B and 40B. Well, this one's easy. The 40s cancel, and I get 24B. This one, the B's cancel, and I get 24 times 40. 24 times 4 is 96, so it's 960 equals 40B, right? And then all we do is solve it. 960 equals 16B, because I bring this over here and it becomes minus 24B. Divide by 16, and I get B to equal 60 minutes. So the boy takes 60 minutes. And that, ladies and gentlemen, is it. So you see how they're all the same. It's still our unit, our amount of work times the time, always. I'm going to stop it and load it, and it'll be 9:50, sorry. So if I had a